Well, hi, good morning, and thank you so much for joining me here on July 20th. Another beautiful day here. Yesterday was fantastic, sunny all day, nowhere's near too hot. Wonderful. Today is going to be cloudy, a little rain coming later. And I know many people, perhaps you, are in part of the world that's just frying right now. And I feel a little bit guilty because the weather here has been really wonderful, in fact. A little too much rain, I think that's all I would say. Okay, so what about this radio? So I have ordered a new dial face to replace the faded one here. I was very surprised. Actually, the owner of the radio discovered that you could get one from a company I have bought quite a number of dial faces from over the years, a company called Radio Days. I'm not affiliated with them in any way. I'm not doing any kind of promotional thing here. But I have bought a number of dial faces, glass ones, and things like that, and it's always been perfect. They always have been perfect and not ridiculously expensive. So if you're working on these old radios and you got a dial that's faded, you should really not only check out Radio Days, I'll spell that, right? It's radio with the word D-A-Z-E after it. Check out what they have on their website, but by all means, send them an email, tell them the radio you've got and what your problem is, and they may be able actually to suggest alternate dial faces that may work on the radio you're on. So you don't have to. So I mean, this is going to look fantastic when it comes. When's it going to come? Maybe in a week, maybe in 6 weeks. I don't know. I don't know right now. So what I'm going to do today is I'm going to kind of rehearse the process of aligning the RF circuits, that'd be the local oscillator and the antenna circuits, as per the instructions, and just kind of practice at it to get familiar with it. The first thing I have noticed here, and I'm now reading the documentation carefully, and we're not going to go through this word by word by any means, but there's long explanations here covering two different radios. So the radio I'm concerned with, and the part of the instructions I'm concerned with, is right here. Step 1, Step 2, Step 3. And I'll read this very quickly, but I won't try to understand it. Loosen the shaft coupling set screws using a wrench, then turn the tuning condenser to the maximum capacity position with the plates fully meshed. Turn the selector knob until the dial pointer is on the small black circle at the low frequency end of range 1 scale. Here's a diagram showing a little spot there, a little dot and the pointer and the like. But things get a little strange after this. With the condenser and pointer set in this position, tighten the set screws. Now, turn the selector knob clockwise until the dial pointer moves 1/16 of an inch from the small black circle, as in Figure 5. So you can see it's actually, there's the small black circle, and they've moved it over a little bit. Leave the pointer in this position and loosen the coupling set screws. After loosening the set screws, turn the selector knob until the pointer is again on the small black dot at the low frequency end of the range 1 scale. Be careful when turning the selector knob that the position of the tuning condenser is not disturbed. Tighten the coupling set screws with the condenser and dial pointer in this position. So I'm certainly not going to undertake that today, because I'm going to be replacing the dial face, and it'll become important to do it after the dial face is put there. But that's a complicated procedure, and what it tells me when I look at this diagram and see the little distances here, that this is a precision operation. You got to get this right, and a little bit off, and the radio's operation will be deteriorated to some degree. So that's a big deal. Not doing that today, though. We already looked at the intermediate frequency tuning just by passing, I think it was 470 kilohertz, I think it was, through the radio, 470 kilohertz, and seeing that there was only one peak. And so that suggested to me that the IF is tuned properly, and I've left it alone for now. There'll be a final alignment process done on the radio. This is just me practicing right now, and so I may very well go through the IF alignment in detail eventually. But at this point, not necessary, certainly not because of a terribly weak radio. This is, I wouldn't, that's not, I'm unfair to your radio. Not terribly weak, just weak. Okay, so what we really want to do is the radio frequency alignment. Tuning range 5.7 to 18 megacycles. Insert the signal generator output lead in the medium jack on the panel. They're talking about the signal generator panel. Connect the other end through a 0.1 microfarad condenser to the red terminal of the aerial panel of the receiver. The output lead ground must be connected to the black terminal or to the chassis. Okay, that's straightforward. Hook up the signal generator to the antenna with a 0.1 capacitor. Leave the receiver volume maximum. Now there is some instructions here about how to connect the meter, which is something I should really pursue. And I've lost track of it. But in here somewhere it says connect your audio meter, AC meter, to the plate and I think it said cathode, between the plate and the cathode of the output tube. I've done 1 or 2 radios that way. Normally I stay away from that because I just don't like bringing the higher voltage out. But I think we'll follow what it says here. I may be mistaken here because I'm doing too many radios. Trying to get at the AVC was difficult in this radio, but maybe I'm mistaken. But we'll follow their instructions here. And then from there it's just a pretty straightforward process. Note, to accurately adjust the high frequency oscillator compensator to the fundamental instead of the image signal, turn the oscillator compensator to the maximum capacity position. Now slowly turn the compensator counterclockwise until a second maximum peak is obtained on the output meter. The second peak is the fundamental signal and must be used in adjusting the receiver for maximum output. The first peak from maximum capacity position of the compensator is the image signal and must not be used in adjusting the compensator. So I have had radios that have been aligned on the image signal. It makes a big difference, believe me, when you correct it. If the above procedure is correctly performed, the image signal will be found much weaker by tuning the receiver dial to 940 kilocycles to 940 kilocycles below the frequency being used on any high frequency range. So they're even saying, even after you follow these instructions, you better check it and see if you got it right. That's what they're saying there. Okay. Okay. Location of compensator adjustments. Where are they shown? They must be shown somewhere. They're going to be up on top here. I saw them somewhere. There they are. There they are, right here, right in front of my face, for crying out loud. So this diagram shows the location of the various adjustments. There's the 2 IF transformers here. There's an adjustment, 2 adjustments on the capacitor itself. A trimmer capacitor mounted right on the big capacitor, and then 2 adjustments here, 7 and 7A. So I won't be bothering with these because I've determined they're good enough for now. To me, they look just fine. They don't need adjustment, but we'll leave these alone, and we're going to go after these. Here's the little chart. Compensator in order. 4B, see note A. Okay, I already read note A. That's about the image, not tuning it up on the image by accident. 4B. 4B, well, it's just here. It's right here. Right behind the bracket there. Now this is a little bit of an unusual looking adjustment. This guy here. How do you adjust this? So it looks like a small locking nut, a larger controlling nut. You can see a springy piece of metal right in here, probably pushing it up like this. So you loosen off the locking thing, and then you adjust with a larger nut, and then when you're happy, you lock down the locking thing. Is that? I don't think it says anything in here about how to do that. I guess they figure people doing this work must know something. I don't think there's any instructions on how to do that. Usually it's just a screw here. You just turn a screw. Why all this complications here? Let's take a closer look at this with, this is why I'm doing this, is to learn all the ins and outs of this particular radio. So let's get the other camera going and take a closer look at it. Now I may have a focus issue with this camera. Let's see. Yeah, so the autofocus is on, so there's a split. Well, it does look like this is a locking ring, this outer part, with a split. You're just supposed to just... Ah, come on, camera, don't do that. There's the spring metal there, just under the that brownish non-conductive material, whatever that is, some kind of phenolic or plastic or something. Look at the other one. Any difference? Better look at the split there. Come on, camera. Be my friend today. Come on. There. Unless that split part is actually connected to the bolt and they're all one thing, or the nut rather, and I just turn the nut. If you really want to put a nut driver on that, wouldn't you? To adjust it, grabbing it with a pair of pliers. That's a pretty small. That's a pretty small. Pretty small. I'm going to bring a great big piece of metal like this up against it. Oh, this is going to be too big. This is a quarter here. No? Well, that'll do it. So you just what about this upper part? Okay, I don't want to fool with it until the set's running and everything like that. That's how that would be done, though. And that is the only adjustment, isn't it? This first step. What we could do today is we can find out if it's definitely on the peak or on the. We can do this. We can kind of experiment with this a little bit. 4BC note A. So I'm going to have a coffee. I'm going to read this more carefully, and then we're going to take a shot at it. Okay, while I was drinking my coffee, my phone beeped. Message from Environment Canada. Severe thunderstorm watch for Aurelia. Which is where I am. Okay, so a watch means just that. Keep a watch. Warning means run for cover. Okay. So up here is the instructions for the output meter. It's connected to the plate and cathode terminals of the 6F6G2, the output tube. Use the 0 to 30 volt scale. Advance the attenuator control of the generator until it reads. Okay, so let's make that connection then to the plate. Now let's take a look at this first. There's the plate and the cathode. The cathode is completely grounded to the chassis. So so I can hook up my ground lead. I just hook it to the chassis. That'd be good enough. Then we just got to pick off the plate of the 6F6. That's the 6F6. Disconnect the brake here. Take the brakes off. 6F6. Get it right. That's this guy here. Which pin is the plate? I remember it as being the pin number 3. Let's see. It's a memory test. I don't pass many memory tests anymore. 6EF. Which I never did. Never ever was any good at memorizing stuff. Don't know why, but I'm just 0 on that. Yep, plate 3, got it right. Or pin 3 is the plate. So you go pin 3 to the chassis. So without the radio being switched on, I'm making these connections. Okay, so we'll take the meter, just going to go on the count on there, and then need a clip lead. I'll have to take a look at the radar in a few minutes and see just where the storm is, how much time I might have here. Probably a lot of time. Okay, the plate, pin 3. I got the right tube right here, pin 3. Let me just make sure I don't get it wrong here. 1, 2, 3. Pin 3 is this one here. Ooh, that's not a very good connection. Clip lead with slightly bigger clips. Let's try this one. There, that's not going anywhere. Put this here. This is an AC measurement. So I'm going to put my probe over to the AC setting. Switch on my voltmeter, let it get warmed up. That's one thing ready. Now, next thing is the output from the signal generator. Let's flip it on at this point. Make sure the output's a little low. The output was to the antenna. Oh, let's get over this. The antenna's here. Red. I'm going to go on the inside here. Let's get a much better clipping. And the other one was on the black or the chassis. Yeah, you can see the black terminal here. The wire goes straight down to the chassis there. Interesting that they have it wrapped the distance, as if that will somehow help. The red wire has the antenna signal on it, and it's heading over to here. Interesting stuff. Okay, signal generator is connected. Signal generator is modulated at 1,000 hertz. Has a nice tone to it. And where the instructions go. Signal generator connected, the voltmeter connected. We're ready to turn on the radio. I guess I can do at this point because it needs to warm up too. So volume down. Here we go. Okay, and nothing bad happened. Good. Signal generator should be set up around, where are we heading here? 18 megahertz. So we're a little low here, 500 kilohertz. 18. Okay. There we are, 18. Okay, radio seems to be in good shape. I'm going to give it the full supply voltage, turn it up a bit. Not much coming out of it. Okay, now we're on the wrong band. Where are we? We are not. We're on the right band. We're not tuned to 18 though. It's 18's about there. More power here. Okay, let's get this happening here. So we should be able to hear that if everything is correct, but of course, I'm sure it's not. We'll change the frequency and try to get the signal to come in here. There it is. is. So there's one of them anyway. Now, that could be the image, or that could be the fundamental. They use the word fundamental. That's a good word. So, turn down my brightness here a little bit. So let's see. We got something here. Would it be just the IF frequency? Just under 500 kilohertz away, we would find something else. I think it's almost a million. You got to do two 470s. So that's 940. So 940 away. This is fading out. How come it just faded away? Could be tuning. So I'm going to tune the signal generator. It's a little easier. Yeah. So something's drifting. It won't be the signal generator. If it drifts, we'd know because the numbers would change. The signal generator does not drift. The radio's drifting. It's still warming up. Now you can see that it kind of highlights the criticality of, in this case, with this radio, having it really warmed up properly. It's fading again. So typically, I think most instructions would say operate a set like this for about 15 minutes before embarking on this kind of thing. The tone you hear is from the signal generator. Okay, let's take a close look at the... Ooh. What's that? Oh, some signal just passing by. What was that? Let's take a look at the dial up close. See where we're actually set. Wow, okay, so I just lost 40% of my hearing. What happened? It had nothing to do with the camera. Oh my gosh, I almost broke out in a sweat there. Wow, that was a ear splitter. My ears are ringing. It's another good reason for not doing things with the volume up full. Well, something happened. What happened? It's still happening. This is another oscillation. The last time there was an oscillation that came on the broadcast band when the dial was turned all the way down here. We're on a different band up at the other end. Can't say I like this. You know what? One thing I forgot was the 0.1 capacitor. Let me disconnect the signal generator and just see what happens here. Okay, let's put in the 0.1. Oh, my ear. I don't know, is it my ears went dead, or is it just disturbed the wax in my ears and now I don't hear the same? 0.1. I wouldn't expect this to make that much difference, but who's doing this? It's got to be the radio itself. Oh, these are the kinds of problems you don't want to have. That's for sure. Boy. Okay. Just as usual, I have just contacted the enemy, and my plans have gone down the drain. That's why Churchill is quoted, anyway, as saying, "Plans are nothing. Planning is everything." It's very, very wise observation. So, it's not the plan, it's the people who put the plan together. That's what's valuable, because they're going to have to put another plan together, and so am I. What are we going to do here? Carry on with trying to do some kind of, I don't know. Is this something to do with the signal generator being connected to the radio? What if I just stick an antenna on there? What do we get? What do we get? Okay, so it's starting right just past the top here. Let's just stick an antenna on there. Ah, son of a gun. Ooh, jeepers, creepers, creepers. I've been stabbed. Hey, this is going downhill fast. Oh man, look at that. I'm bleeding to death. Okay, we're going to do the experiment and I'm going to stop because look what's happening to me here. Okay, antenna going, I'm bleeding to death. Performing the experiment. It's a different location. So it has something to do with the antenna side of things. I can't imagine it's an alignment issue. Wow. Okay. So I'm bleeding here. Yeah. Well, I'm going to stop for a bit while I deal with my poked finger here. Man alive. That was painful. It still is painful. But I'm not going to cry. Okay. Gotta go to the local hospital here. That would be my washer. Okay, another thought came to mind here. Is it my voltmeter connection that's causing the strange oscillation? So we are going to initiate the oscillation here. Initiate the oscillation. And we're going to disconnect the voltmeter. No. That's not causing any problem. Another thing I'm going to do is take the ground off for the signal generator. And that did nothing. And so we have basically the radio. Oh, let's take this ground off for the meter. Basically, I have the radio sitting here hooked up to an antenna. So look at the pitch of the oscillation changed entirely. Oh, apparently, I'm not very good at oscillations. For an oscillation to happen, there has to be an amplification taking place. Otherwise, the oscillation, if it started, would just dampen out and disappear. And it happened like that. Wow. Today I'm a magician. I'll just fool around a bit here before I get too excited. Is it restricted to this little area now? What in heaven's name is happening? Wait a minute. This is really very annoying. Come back problem. I turn the volume up. Stand back, everybody. Need a little oil in here. Well, this is not going well. It could be the band switch. Band switch could be involved in this. Okay. We hear the radio. I never heard it before. I think it's picking that up. Whatever that was, it's gone now. Yeah, how can you align a radio with this kind of stuff? Okay, well, I think that's coming in on the antenna, but I don't know. Hand on the volume control. It's working quite... It's totally happy now. That's full volume though, so it's still low volume. Come on, radio. Don't, you know, tease me with a problem, and then when I start looking into it, problem fades away. Maybe we can stick it out.
Its national flag is one of the oldest in the entire world, going back to 162 BCE. Wow, I didn't realise that any national flag was that old. Well, you live and learn, don't you? Now then, what is today's question? Well, Ayaj, forgive me if I'm mispronouncing your name, has a great question. He writes, "Dear brothers, thank you for your broadcasts. A friend shared one of them with me, and I'm really interested in hearing more. I don't have a shortwave radio, and I don't have the time to sit and listen to a recording from YouTube. Is there any other way I can..."
Nothing. It's fading away. So that's just fading radio signals, I'm pretty sure. Not the radio. Oh my, although maybe it tuned a little bit. Oh, it just totally went away. Didn't even know it was there. I guess the radio's more sensitive in the area where it was oscillating. Do we have it just turn, just... Okay, we're ready to go again. I don't know what else to do other than to press forward with the whole operation here. You know, I did a silly thing. I took the ground off my voltmeter, but left the voltmeter actually connected. That's not the best thing to do. The hot lead. Okay, put the ground on. Yeah, I'm a chicken. Are you a chicken? I'm a chicken when it comes to doing that. Okay, we're going to put this on. Take off the antenna. Clunk. Put on this guy here. This is the signal generator. Oscillation back. They wrap the wires coming back here, twisting them around each other to stop oscillations. Hello. Okay, now we're going to put this at 10. No, up around 18. Ooh. Another station. That's Brother Stare. I thought I heard him. So I'm just going to run and make sure the antenna's switched on. I'm going to leave the camera running here. I'll be back in 14 and a half seconds. Okay, should have got a little better there. There's some volume there. Well, I don't know, oscillation gone away. So we'll go back to 18 megahertz. Just about to look at that with the... Okay, we're on the antenna too, so we're going to come off the antenna. Hold on, volume down. Because this radio got me to bleed on my finger. It's going to try to make me bleed out of my ears too. Ooh, careful there. Signal generator. Not oscillating. Okay, so we're tuned to around 18. Let's see what we got up here. 18138. Lovely. Let's look now. Okay, I'm right back where I was before when the whole thing went wild. I'm going to switch cameras. Oh, wrong button, Jim. Now, where are we actually tuned? That's pretty much dead on 18, isn't it? There's the dot. I'd say that's 18 there. 18, eh? A little off, 18,135. So, first adjustment on this is the oscillator. I'm pretty sure that's what the 4B was. I can't even remember the instructions now, so much stuff has happened. I can't remember the key thing. The key thing is 4B, note A. Oh yeah, that's right. We were going to try to let's follow the instructions, and we'll see where we end up. Now, are we already on the what I'm going to do is I'm going to turn up the signal generator, and then I'm going to tune the radio roughly 1 million in each direction. See what we hear. Okay, so we're going to go up a little bit louder here. Wow, that's a lot louder. Something was microphonic. I think there's something microphonic in my signal generator. And when I changed bands, it made the plates vibrate in the big capacitor that must be in that thing. Make that musical sort of note to it. Okay. Oh yeah, we're going to go... I can't remember what I'm doing over the course of just a couple of seconds here. We're going to go looking. A megahertz this way and a megahertz that way. Do we find another tone? I don't think that's a megahertz. Let's just crank this up a little higher. Okay. Now the question is, which one's louder? That one? Or that one? So that might make you think, oh, well, clearly, this one over here must be the image, and this here must be the fundamental. But what can happen is somebody could have, and I don't think this happened with this radio, but it could happen, where somebody tunes it up on the image, and the result of that is the image will sound stronger than the fundamental, and you'll be confirming the incorrect setting. This is tricky. This can be tricky, especially for somebody like me. Very tricky. Okay. Following the instructions would be a good idea at this point, because that is really what I'm trying to do. I'm trying to practice the instructions here. So 18 and 4B, note A. Note A. To accurately adjust the high frequency oscillator compensator, the fundamental, instead of the image, turn the oscillator compensator to the maximum capacity position clockwise. Now slowly turn the compensator counterclockwise until a second maximum peak is obtained. The second peak is the fundamental. Crank it down, turn it back 2 peaks. Second peak is the one we're after. Notice they didn't say the louder one? Okay. Now, what about this throwing everything off? I don't think it will. Great big tool going on there. And what about that locking nut? We're just going to power it. Just maybe it's not really a locking nut, it's more a friction thing they've got going here. Okay, let's try turning this a little bit. Oh yeah, it turns easy. Yeah. Okay, don't turn it anymore. Was that 4B or did I just turn the wrong one? Just double checking. Because I have a way of making mistakes. Okay, no, that's the correct one. So we're going to adjust the oscillator by turning that. So we need everything set perfectly. So with my own eyeballs, I'm going to set this to 18 using the proper scale. And what I mean by that is I started looking at the AM broadcast scale for a minute. So the radio's now tuned exactly to 18. We want the signal. We want to turn the signal generator to 18. Not how we would normally do this, but we're going to follow their instructions. Okay, there's 18, and we're going to crank this guy down tight. And I think we should hear. Well, I don't know what we're going to hear. There it goes. What's that popping? Whew. Okay, volume down a little bit. Okay, that's pretty tight. Now we're going to go back steadily, looking for the second one. There's one. Do you hear it? One there. Oh, baby. Don't do that. Okay. I don't know what that was. Keep going. Oh, another one. Very faint. This is having a wee bit of an effect. The tool. Carrying on. So that should be it. That should have been it. 1 and 2. But I don't think it's it. I think there's lots more in here. There's one. That was pretty strong. Where's number 2? Hello, number 2. What's going on with this thing? Is the problem reading this capacitor? When I just touch it here, we get little clickies. Probably get the same thing. Can't hear it. When I touch the big screw, tighten her back down. There was one huge signal in this radio. And there it is. Just doing this by ear today. Did we get it really right? Whoops. That's really close, I'm sure. I mean, you can't dial in these frequencies to this precision on this radio. dial's very inaccurate or imprecise in that respect. So that's good enough. What do we do exactly? I don't think we did much of anything here. We moved the frequency so that when the dial says 18, the receiver's receiving 18. Let's look for the images. So, two ways to do this: move the radio around frequency or move the signal generator around. If we move the signal generator around, the image frequency should show up quieter than this one. Let's try that. And we can read the frequency too. The radio is difficult to do with this. I'm not speaking words. No words happening anymore. I hear nothing. Going up now. There it is. So we're picking up the image. I'm able to, the proper way to put this is I'm able to feed the image frequency into the radio and hear it, but it's much quieter. Oh, going the wrong way. Okay. So a radio like this uses a local oscillator to mix with the incoming signal. You tune the local oscillator to within the IF frequency range, 470 kilohertz. So you're tuning the radio, you're tuning this local oscillator. When you get 470 kilohertz in between here, it's going. 470 between the local oscillator and the incoming signal, and it comes through the IF. But the problem is you can get 470 over here. You can get a signal down here that is also 470 kilohertz away from the target frequency. You can hear this. The only reason this one is going to be quieter than this one is because the front end of the radio has a tuning curve, and you're trying to make the peak of that curve, we haven't done it yet, or match the fundamental frequency. And when you get off to the image frequency, it's suppressed by the tuning response. In a radio like this, tuning one band using 470 kilohertz at 18 megahertz, the image is almost certainly hearable. Fainter, but hearable. The problem in using a radio like this is if you're tuning a station, let's say at 18 megahertz, and there happens to be a station at 470, you may hear the 470 station at 18. And that's what you're trying to suppress. Different radios suppress this in better or worse. Really, really good communications radios will suppress this. Mostly they do it by not using 470 kilohertz. Because it's too close. So 470 and 18 megahertz, from 0 to 18 megahertz, 470 is just here. So what they do is they use a different IF with a much larger frequency, usually 10.7. So in this case, this puts the images way off. And by the time you get there, the radio's front end tuning has really suppressed it, like just knocked it right out. That's how a communications receiver, that's why you'll hear the term double conversion, because it's not converting the frequency once, it's converting it twice. Yeah, usually converts it twice. It uses the 1070, converts the frequency down to 455, or I'm going to get this wrong. And then it's, yeah, I got it wrong. I won't say anymore. Won't say anymore. I know how it works, I just can't say it. Okay, so the next thing now is the front end tuning. We're using a signal generator. It's got a capacitor in the circuit. It's actually got another capacitor inside this box. It's another little capacitor to make the radio think it's hooked up to an antenna, but may or may not be the best. I got this meter hooked up over here. I never paid attention to it. I'm saying I'm doing it by ear, but I actually have a meter hooked up. did the meter do anything? Let's check this, because again, this is a practice session. You know, the real event comes later. Okay, so we're tuned into a signal. This is set to AC, but high voltage, so it's up here a little bit. That's probably a zero error right there. We'll go down, 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 down. Okay, let's go here. That's 5 volts now. It said use the 30 volt scale. So I'm going to tune the signal generator on and off the frequency, and that meter should go up and down. Lovely. So when the time comes to do a precision alignment, be able to use this meter the way they've suggested. It's probably a standard procedure I should be adopting with all radios. I tend to use the AVC voltage because you're not connecting into a plate. I'm not bringing a plate voltage out onto your bench. Okay, Jim, what are you doing? So now we're going to try to peak this signal up. I could do this with the antenna actually, but we're not. We're going to do it with this. And I know as much as I'm sure of what I'm doing, I'm going to look at the instructions. Because being sure of things is a problem. Don't be so sure of things. Well, that was it. That's all there is. You just adjust the local oscillator to maximum. There is no antenna adjustment. Wait a minute. When do you adjust? There's a 4A on there. 4A. 4A. Where's 4A in the instructions? Never makes it? A, 4A. What? Again, this is why I like to do these things first time through, quite relaxed, not too concerned about success, just to work through all this nonsense. If you encounter these kinds of things while you're trying to do a precise job, it's very frustrating. So better to encounter them while you're relaxed, sort them out, and then when you're ready to go, like a race car driver checking out the track ahead of time, so he knows where all the curves are before he steps on the gas. There is no, there it is, 4A. So 4A is done on the broadcast band. Okay, we're going to do that. I'm just trying to decide if I should stop for a minute. Now let's carry on. Let's carry on here. We're carrying on. So volume down, band change, 1500. Okay, so let's tune to 1500 now. Compensators in this order, 7A and then 4A. So 7A is there. 7A is on the outboard side of this. Oh, it's way down there. There it is. I see it. I'm going to go with a long screwdriver. This is a big honker. A lot of steel in here. Further. There he is, down there. Okay, what am I doing? I got to do a couple other things. I got to get the signal generator set right also. 1500. Okay, wait. I can just look way up here. 1500. 1500. It's a very strong signal. There it is. Yeah, I just turned the volume up on the radio. It's right there. That's pretty good. I'm looking at the dial now. The dial is, let's say, dead on 1500. This is dead on 1500. So we just want to max this out, but I can't imagine there's much adjustment required to peak this. In fact, fantastic. You can get a look at the meter there. Okay, make that meter go up. First, screwdriver sensitivity. Nothing. Okay, going in. Screwdriver far too big. Oh no, it's right on it. Is it? No. Did I turn it? Okay, thinner screwdriver. How about this really long antique one I've got? Look at this guy. It's really not the best one to use for. I gotta turn it back and forth. I can put the lock on in the middle here. What about this guy? Any effect? No? Does he go in? Oh yeah. What's that meter doing? Okay, so the meter's doing nothing. This is bad news. These are all the things I want to find out. Why? Let's not use this big metal. Because you know what? I've got really good plastic ones to use. It's just in the dark here, trying to spot them. There it is. Okay, so it's a nice fat plastic one that's got really quite stiff. Okay, watching the meter. Oh, there it goes. Good. Okay. Perfect. Max it up. There we are. Okay, meter is maxed. Next step here. Oh, 4A. Now we do 4A. So 7A. I don't know. 4A. 4A. It's this guy. Come on, camera. Back up. Watching the meter. What's that snap? We're up. Okay, a little tiny bit there. So that's 7, 8. Now we go to the other end and we do number 7. Then we come back and double check on 7, 8. So we go to 580. Why not 600? Why 580? Okay, 580. You'll have to trust me. That's 580. Oh my gosh, what's happening now? Okay, we're going to go to 600 and do this because there's no oscillation there. 600. What about these oscillations? They're all related to the same thing. What'd I say, 600? Yes, 600. Ay. What's going on there? Wow. What? What was all that? Okay, so I'm gonna tune through from down here. That's just above the IF frequency. And just watch this meter go. Give you a good idea of what's happening. I'll try and do the frequency as smoothly as I can here, going up. We're going up. Okay, and we're not even at 600 yet. Here comes 600. That was 600. Isn't that a... Let's keep going. 700. 800. 900. And that's 1,000. That's as high as I can go on this band. Well, what do you make of all of that? That's just crazy. Okay, back down around 600. So that's 600. But if I go down lower, we can do a lot better way down there. This is 490. I hit 470 very soon. This is 470. Nothing. I thought 470 was the IF. Giving it a shot of power here. Okay, I'm getting some suggestions here that the IF is not tuned properly. Because I'm going through the IF. I'm at 4. Got a lot of power coming on my generator. 463. Let me turn the volume up. 463. We're just going up for 500. Oh, that's 400. That's 390. Wow, something's way out of whack here. I think maybe I misinterpreted the IF the first time through as being okay. Because the fact that when you tune the radio to a station like 600, it's all over the place. As if there's multiple points at which it can tune in. Now, there's 4 different coils in here. Each one of them can have its own resonance. The idea is to have them all like here's the 4 of them. The idea is to get them all lined up like that. But if you don't, if they're like this, for some reason, then you could hear potentially every one of these. Normally they're really close, so hearing them would be difficult. Instead, you'd hear kind of a combination of them, sort of. It wouldn't readily be apparent that they're like this instead of like this. But if they're like this, you get a very wide response and reduced level. So I think tomorrow we're going to go after the IF here. As I've learned, and I would recommend to anybody, when you get to this stage in doing a radio repair, really, the first time you try to align it like this, just accept the fact it's going to be an ugly mess. Maybe it won't be. But if it is, then you won't be so disappointed. If you attempt the final alignment right off the bat, you might end up quite upset. And the whole objective of this, I seldom say this, the whole objective of doing this kind of thing is to make sure it's not like work and it's more like fun. I mean, that's a pretty good objective in life, generally. But as soon as it starts feeling like work, what are you going to come in here for? I don't want to do work. I want to have fun. So I try to approach things on that level. Stay away from the pain, the blood. Focus on the fun. Well, that's the fun for today. I am through here. And maybe what we should do, the last thing, I'm going to take a look at the radar on my computer. So let's turn this off before I forget. Turn off all my equipment. Okay, and we're going to take a look at where is the thunderstorm? Okay, quick look at the weather map. You can see the Great Lakes here, and I'm located right here. You can see a little bit of a storm there, so we can kind of zoom in on this area. You can see Aurelia, that's where I live, right there. You can see the storm is actually quite a ways up. This is 50 kilometers up here. But let's play it. Let's play it. Well, they're going the other direction. So nothing imminent here in Aurelia for now. So I'm surprised we actually got a watch. Okay, well that's good because I'm going outside from here. So thanks a lot for watching, and tomorrow we'll look at that IF much more closely and see if we can sort something out. And as for the oscillations that are showing up, I don't know. Maybe if I'm lucky, it'll all go away when everything is straightened out. Maybe the terrible alignment of the IF, if that's really the case, is also responsible for the weird oscillations. I don't know. Okay, well thanks a lot for watching, and we'll see you tomorrow.